All right, we're done with the done with the cycles. There are no more cycles. Of course, there will be quiz questions and so on. Speaking of quizzes, I noticed that maybe 3/4 of you had already finished today's quiz. That's good news. The rest of you make sure you get it done by 3 o'clock. All right, so energy and ecosystems. Everything in an ecosystem is cyclic, except energy. So nitrogen gets used over and over and over and over and over again. Water gets used over and over and over and over and over again. In fact, it's a little disturbing to think about, but you could, last time you drank something, everything we drink is water-based. Last time you drank something, you could have drunk a molecule that was Napoleon sweat, woohoo. Or you could have drunk a molecule that was in dinosaur urine. How exciting, eh? Don't worry, it's all been purified by the process of evaporation. But the amount of hydrogen and oxygen in the world is fixed. So the water that we drink now is the same water that's been used countless times since God created it. The amount of nitrogen in the world is fixed. So the nitrogen in the protein that you had for lunch, and it's hard to imagine a lunch that doesn't have at least a tiny bit of protein in it. I mean, maybe if you ate ramen noodles without the broth, there is not much protein in the broth, but there's got to be a little bit. But anyway, the nitrogen in the protein you ate for lunch there's a fixed amount of nitrogen in the world. It's been cycling and cycling and cycling since God created it. Everything in an ecosystem is cyclic except energy. Now, energy might be reused a few times, but by cyclic, I mean the same energy, the same nitrogen, the same carbon, the same water, the same oxygen, the same phosphorus that God created has been used over and over and over since the day of creation. When I say energy is not cyclic, I mean we constantly keep having to add more because we're constantly losing it. And if we quit adding more, the whole process would stop surprisingly quickly. Yes, the energy is reused 2 or 3 times, but not forever. All right, so energy and ecosystems. Almost all food energy on Earth comes from the sun. As I've mentioned a few times, there are some bacteria and so on, particularly deep in the ocean, that can use certain inorganic minerals that bubble out from the core of the earth, but that's pretty minor compared to any food chain that we personally are involved in, at least. So almost all food energy on Earth comes from the sun. Constant input of energy, producers harnessing that energy and it being consumed up the food chain. Plants produce organic energy, that is food, from inorganic energy, that is light. They get their energy from light, but listen, the plants use light to make glucose, and glucose is their energy store. Their cells use glucose just like our cells use glucose. So plants can make their own food, but they have to eat, not really eat because it's already in them, but they have to use the organic food that they produce from sunlight. They don't use the sunlight for the cell's energy. They only use the sunlight to make glucose for the cell's energy, but because of that, they're called producers. Every other living thing on Earth consumes the food energy that was originally made by the plants. So everything else on Earth is some kind of consumer. Now, we normally think of consumers as being animals that eat other plants or animals, but some consumers, like let's say earthworms, are eating broken leftover pieces of animals. They're not eating it, or plants. They're not eating the plant or animal in its original sense, I guess. So, energy and ecosystems, specifically food chains. Food chains is a kind of vague but kind of important concept. A series showing what eats what is called a food chain. Now, we can do a specific food chain like this grasshopper eats grass, and then a mouse eats the grasshopper, and a snake eats the mouse, and a hawk eats the snake. That would be specific, or we could do it generally, as in all of the producers. There's not just grass, there's, oak trees and ferns and mosses and whatever else. And there's not just mice, there's rabbits and squirrels and whatever else. So we could do it a specific food chain: grass, grasshopper, mouse, snake, hawk. Or we could do a more general food chain: producers, primary consumers, secondary consumers. We'll look at something like that in a moment. Now, this is perhaps one of the most important ecology concepts there is. You can count on seeing several questions about this. In every step of the food chain, about 10% of the available energy being basically defined as whatever we're talking about ate. But 10% of the available energy is passed on to the next step. Now, there's another way that this is sometimes stated, and you're going to have to watch for this. 10% passed is the same as 90% lost. So keep in mind, these two are the same. Now, people get too quick. They answer the question too quickly sometimes. And say, oh, 90%. Oh, that's wrong. It's 10%. Well, if it says 90% lost, that's the same as 10% kept. So pay close attention to this when you are answering quizzes and so on. Now, for example, I'm sure that each of you has a different appetite, and I'm sure that your appetite changes from day to day. But let's say over the course of a day, you ate, for easy figuring, a pound of food. So there's 365 days in a year. That means that in a year, 1 year, if you eat a pound of food per day, and some of you are undoubtedly more than that. Some of you, I doubt that many of you are much less than that, but maybe. I've never really figured out how much a meal weighs other than a quarter pounder. Duh. But so there's 365 days in a year. That means that we eat somewhere in the range of 365 pounds of food per year, 365 pounds a year and up. And unless some of you have really hit the fridge since I saw you last, None of you are even close to 365 pounds. None of you come even close to weighing as much as how much you've eaten just in the last year. So what? If you're, man, what are you people, 16, give or take? Okay, so your first few years you didn't eat a pound a year. Uh, so let's say it averages out, let's say the last 10 years. In the last 10 years, you've eaten 1.75 tons. If we multiply the 365 by 10. Whoa, 1.75 tons? Whoa. And yet here we are, 120, 150, 170, however much you might weigh. So these are huge numbers. It's because 90% is lost in each step of the food chain. This is a very important ecological principle. So here's an example of a food chain. We have an input of energy from the sun, of course, because all energy on Earth comes from the sun. And by the way, we haven't talked about biomes yet, but temperate deciduous forest is the natural biome for southern Michigan. I mean, not many of us, some of us, but not many of us have our house in the forest. And there's cities and so on where there's not really a forest, there's just some trees here and there. But temperate deciduous forest is what would occur naturally here, what was here naturally before European settlers started cutting things down, and what this would return to if, heaven forbid, some disaster 100 times worse than COVID wiped out humanity. So producers are plants, of course. They're eaten by primary consumers like this cricket. Secondary consumer, this is basically what I was talking about earlier. Secondary consumer like a moss eats the herbivore, the cricket in this case, some snake, except I've never seen this kind of snake living in our temperate deciduous forest. Third degree or tertiary consumer eats the mouse. That should be quaternary. Fourth degree consumer eats the snake. And ultimately, the hawk dies, and some of it leaves droppings behind, it defecates. And then these dead materials and feces and so on are recycled by the decomposers like the mushroom, so that the nutrients like the nitrogen and potassium and phosphorus can be used over again by the producer. But this is the food chain, or a typical food chain in a temperate deciduous forest. Obviously, there's a lot more than grasshoppers or crickets, a lot more than mice, a lot more than snakes, a lot more than hawks. And so we can show all of the interacting relationships. We would call that a food web. More on that later. Now, we illustrate this principle of the 10% with ecological pyramids. Kind of like the food pyramid, except I think the food pyramid has been changed in the last few years. Still might be like the ecological, like the food pyramid, but ecological pyramids graphically illustrate this 90-10 concept. Graphically, now, by the way, when we say graphic, a lot of times we mean it's gross or disturbing or unnecessarily explicit. And when I say graphical here, I just mean in a graph form, or a graphic as in picture form. Represents the biomass. Biomass is just what it sounds like. It's the total weight, that was long enough, of living things in an ecosystem, which, you know, may sound absurd, exactly how much does all of the trees and grass and ferns and wildflowers in the forests of southern Michigan weigh? Well, that would be strictly a calculation. And we would want to do a smaller ecosystem if we were going to actually measure it. I mean, we could sample and to get an idea for our calculations of each trophic level. Now, the trophic levels, if you haven't picked up on this, are like the producers is the first trophic level, and the primary consumers are the second trophic level, and the secondary consumers are the third trophic level. So basically, a biological pyramid is trying to illustrate how much more biomass or amount of living things. And we don't say number of living things, because what do? Count a blade of grass? How do you count grass plants? So we just say the total mass, and plus one grass plant doesn't equal one oak tree. So to make things uniform, we just talk about the total mass, not the number of individuals. And just like I said, biomass is total mass of living things in the stated population. Trophic level are the eating levels. I already said that stuff. So this is an ecological pyramid, and it's showing basically this concept three different ways. This one is showing by percentages, and see this heat energy lost is heat. That's where that other 90% goes. So producers represent 100% of the biomass of the first step. If 90% of their mass is lost as heat, that means that 10% makes it to the primary consumers. Now, careful. If you're just sitting there, you know, going to sleep, waiting for me to quit droning on, you're going to miss this. 10% is passed on. That's that 10%. Okay, here it is. Pay attention. What is 90% of 10%? We lost 90%. We passed on 10%. What's 90% of this 10%? It's 9%, which leaves what? 9%. That, by the way, that's 9% of this original 100. So if that's 9%, the other 1%, that leaves 1%, which goes whoosh to here. 90% of 1% is 0.9, which leaves 0.1% to go to the top level. And that is why food chains almost never go beyond like a fifth degree, because there's so little of the energy left. There's just not enough to support many more energy levels. So this is what we mean by it's not cyclic. It may be reused from the first level to the second level, and it may be reused from the second level to the third, and it may be used to the third to the fourth, but by then we're almost out. Now, this one is actually showing biomass, grams is mass per meter squared, except this is aquatic. It maybe should be meters cubed, but anyway. So let's say we have 809 grams in every meter squared of this pond or whatever it is. 809 grams per meter squared of producers. That is passed on to, that is enough to feed 37 grams per cubic centimeter or per square centimeter of consumers, primary consumers, which is enough to feed, whoops, which is enough to feed something's cut off here. Less secondary consumers, I don't know what that number was originally, which is enough to feed 1.5 grams per meter squared of third level consumers, the top predators, which by the way, might be the keystone species. But it takes 809 grams per meter squared, in this case of primary consumers, results in 1.5 grams per meter squared of the third level consumer. And this is trying to give you actual numbers, but numbers just depend on, exact numbers depend on what we're talking about. Like maybe 1,500,000 primary consumers is enough to feed, depending on what size we're talking about, 200,000, primary producers, enough to feed 200,000 primary consumers, which is enough to feed about 90,000 second, and maybe one third level consumer. So every step of the food chain, 95% is lost. 90% is lost-ish, 10% is passed on. And this is a big deal in ecology, and it is a big deal to people who are afraid that we are going to overpopulate, we being humanity, is going to overpopulate the earth. Now, you will hear people tell you that you should not eat much meat and you should eat a lot of mostly plants. And you'll hear people tell you that for different reasons. One reason is some people just think meat is bad for you. Some people think you shouldn't kill animals. Those are different arguments that you can have an opinion on. I'm not talking about that now. But you'll hear people say that you should eat less meat because of world population, so that we have enough food to feed everyone. And that is based on this concept. Because let's say that this was corn instead of seaweed, and let's say, so this much corn